Hi, welcome back to Aprovecho, to our lab. And so today we're going to look at the original rocket stove that was evolved in India, and Dr. Larry Winiarski invented the rocket stove. But when we went to India, they made it shorter, and really it was a year of work with 18 villages where they made the stove work for them, and so that is what evolved the short rocket stove that now is sold all over the world. The great thing about when Larry Winiarski made this, this is 4 inches in diameter, and so he was trying to have all the flame and the gases be concentrated in a small space where he hoped that they would mix and that the smoke would burn up. Unfortunately, laminar flame, which is the tall yellow flames, there's two bad things. One is the smoke can go this way and the flame can go this way. And so when that happens, you can get a lot of smoke. And so there's not much mixing. Mixing is when something is going like this and it's forcing the gases to go into the flame. But the great thing is that Larry invented this top, and when you have that concentrated, really hot gases and flame, and it smashes into the bottom of the pot, then you can get high thermal efficiencies when the stove is low mass. And that's why, because high mass will absorb the energy that could have gone into the pot, could have cooked food. So when we went to Shenzhou stove manufacturer, we went, oh my gosh, look, they're already making, they've been making since 1400s, that area in China, lightweight refractory ceramic. And so that was amazing. And they've made millions and millions of these now, and they're making rocket stoves. And this cost $2.43. So we thought, okay, can we make a rocket stove that makes less smoke? And so we tried something, which is we made the combustion chamber wider. So instead of 4 inches in diameter, it's now 6. And then we looked under the emission hood, and we did many, many experiments, and we said, okay, yeah, that does result in lower amounts of smoke. Why is that? Well, that's because there's less draft with the big combustion chamber, and it makes less concentrated laminar flames that are touching the cold bottom of this pot. And so the design principle is don't let flame touch the bottom of the pot. Can you make a rocket stove where the flame burns out before it touches the cold bottom of the pot? And so that ended up in a rocket stove with a bigger diameter combustion chamber. So 6 inches, not 4 inches. And then you can see that it's narrower. Can you see that, Sam? It's narrower at the bottom. Okay. And that's so that the sticks, only 8 centimeters of the stick is you're encouraging a shorter amount of the stick to burn. And that then helps to discourage those tall laminar flames. They're going to hit the the bottom of the pot. You can see that, yeah, okay, it's wider. The other thing is that it makes the stove lighter, which is great because less heat is absorbed in the stove. And then I think there's only one more thing really. This is the stick support, and the stick support is 1 inch above the floor of the combustion chamber, and that encourages the charcoal to really heat the sticks above that are. So here's the charcoal inside the combustion chamber, and then here are the sticks. And if the stick support is too high, then the sticks are not set on fire by the charcoal. So what we're discovering as we test the new wider rocket is that there may be something called low velocity turbulence. And low velocity turbulence can be encouraged, which replaces the laminar flame in the original rocket stove. So this is what we're experimenting with. And so just to go over again, 8 centimeter of the tip of the wood sticks are encouraged to burn, metering the fuel. The width has been increased from 4 inches to 6 inches. The combustion chamber is lighter, therefore it absorbs less. We really don't want laminar flames to touch the pot. So if you have a design principle, that would be, yeah, flames burn out before they touch the bottom of the pot. We are trying to encourage short, jumpy flame, not tall laminar flame. We're starting the stoves with charcoal, not kindling. And so we use 30 grams of charcoal to start the fire. And larger diameter sticks make less smoke than small sticks. So the width of the stick we have shown here is really important when you're trying to discourage smoke. 1 inch sticks are a lot better than ½ inch sticks in the width for making the least amount of smoke. And then the solid stick support that goes within 8 centimeter of the back of the combustion chamber is really helps to meter the fuel. So thanks very much.